Alright, hello internet. This is Toad Martin coming to you live. Let's talk a little bit about contour entanglement and then contour imprinting. And go into a little bit of diagrams here. Let's say, of course, tine tower, very important. Spin resistance ergometer, also very important. Let's talk contour imprinting. So this is what I call it. I don't actually know if there's a real name for it. Imprinting. So this comes from the lore of the slang of stepping on drugs. It's like, why would people do such a thing? I think it actually comes from literal stepping on a bag of drugs that has been cut probably with racemic, or sorry, it's not racemic, R configuration pure, optically pure ketamine, which is a complicated enough molecule that has enough degrees of freedom that it might actually take on the shape of something else. So suppose that you had, let's see the drop molecule edge on here, just pretend that this is something recreational, whatever it happens to be, and then these are the connected nuclei, and then we're going to have some sort of electron cloud around it like this, and then a lot of these joints might have some rotational ability, right? And so depending how those things were spun around, if you actually had another shape next to it like this is very simplified. Just simply drawing the chemical formula I think is actually unnecessary here. But if you were to actually put these electron clouds next to each other and apply mechanical pressure, like literally stepping on it, let's say you put a plate of silicone around it and then actually press down upon it, you might actually get two contours that actually resemble one another like this. And then that would be the new shape. And then we know from Chemistry for Changing Times, 8th edition by Kolb and Hill, that there are sockets and binding sites that these molecules attach to, usually through the nitrogen, which I haven't actually drawn here. But in those cases, they would then take on the character of the same sockets and same binding sites, more or less, based on where they're located. And so that might make this seem, even though this is, let's pretend this is 50-50, it'd make it seem like it was 100%. Because like that's which is what I think is the origin of the term stepping on someone's drugs. But it's like, I think it actually can literally make a one drug seem stronger than it would otherwise be if you were to give it a inert contaminant. So, but this gives a little credence to this concept of what I like to call contour entanglement, which has another phenomenon that I've discussed over my QM, which is a little bit hard to explain, but I will explain in excruciating detail entanglement. So we know from, let's just talk about regular quantum entanglement here. So let's just say I have one molecule here. Let's just draw an edge on like this. And then let's just say it has a chiral center here like this. And then let's do its opposite symmetric friend just over here. If it's made, this is for a racemic preparation, whatever it happens to be, something of racemic origin. And then its configuration would be something like this. I'll just go ahead and just say this one is R and this one is S, and this is for a racemic origin, which has probability equal sides of front or backside attack of the last reactant to attach to an otherwise planar reactant. Anyways, the point was that this molecule here of this R configuration would have a electron cloud that looks kind of like, I'll just say, let's draw it like this, like that. And this one would have an electron cloud kind of surrounds it like this. And there's a little double hump on there like that. And so we know from quantum entanglement that if we were to push down on these electron clouds here, what happens is that sometimes, just because there was a probabilistic origin for this racemic molecule, that sometimes these electron clouds kind of wave over to here. They have some chance of being on that side. And when that happens, this actually reverses over and you get electron cloud like this. And this electron cloud moving this width, a little bit more than 2 widths of this molecule, is small enough to be detected as a current. E minus goes here and transfers back to here. And if we were to do this fast enough, you could therefore potentially hear voices depending on what this molecule was and where it was attached in the brain, and depending on what socket type it went into. But let's talk about another phenomenon, because I think when I was first exposed to, I'm pretty sure it was racemic ketamine, I've never been able to prove this because all of it's stuck in my brain, you can't actually pull it out of my blood. There is a phenomenon of olfactory entanglement. And so what happened was, because I'm pretty sure it was on my Adderall, what happened is that what I did is I crushed up the Adderall and shot it up my butt. And then another person on my entanglement reported that these contours on this side of the ketamine resembled, let's see if I give it like a little wave here, this resembled butt molecules. But then as the Adderall dissolved and was taken into my blood, apparently it turned into sweet, because it did not digest and turn into barf smell. It actually turned into sugar, because the sugar actually was against it when it was dissolved in the brand name Adderall, which is bound together with sugar instead of say carnauba wax like it is for generic. But anyways, so olfactory entanglement is actually, I think, contour imprinting, where it's not just the wave of these clouds being very nice, the textbook size shape. It might actually be a more complicated contour, something else, and that can still be transferred over quantum entanglement like this on either side. Not really sure. Maybe it goes back and forth, but this is one of those things where it's like, the phenomenon of olfactory entanglement is definitely something to look out for. But I think it has something to do with not only the probability cloud just existing on one side, but actually taking on the shape of whatever it is that it corresponds to and is in contact with through contour imprinting. So in this case, I'm pretty sure this would only apply to a, this would be not racemic, or sorry, it's not achiral, it's not racemic, but because that's the thing, racemic molecules have this degree of freedom where it can be this contour or this contour. Not racemic would be a little bit more classical, where these revolutions can actually adjust the shape of the molecule just like you'd have on a ball and stick molecule model that you do in organic chemistry class. Anyways, these are just my musings as to why something might start out sweet, but then it tastes like, or start out inert because it's just sitting on the very surface of very gently as vapor deposited on a pill, but then begun smelling or tasting aggressively like butt, and then eventually dissolve into being overwhelmed with sugar, because once it was dissolved, sugar was the primary contact against one of these contours of the electron cloud. Anyways, this has been Tobin Martin. Thanks for tuning in. Appreciate the views. Thank you, everyone. Good night.